Alright everybody, this is Mr. Longo here, and this video is going to cover just the changes to your final exam review packet for second semester. There have been some modifications to the units we taught this year, so most of the packet is excellent, but there have been a few modifications, and that's what I'm going to talk about. So if you go to the unit 5/6, powers, roots, and radicals, the first 6 questions are new. So when you're working with radicals, you have to remember numbers, you want to break them apart using the factor tree. And when you get down to the bottom, you will have a nice pretty row if you always divide by the smallest number, but you circle groups of the index at a time. Now remember, this is a square root symbol, so we don't need an index of 2 in there. So we circle groups of 2. So we have a 2 that comes outside and we have another 2 that comes outside. But this 2 doesn't have anybody to play with, so he stays inside as a 2. But then for exponents, what we do is we ask how many times the index 2 goes into 5. And it goes in there twice, so we can pull out x squared. But we have 1 left over that has to stay inside. How many times does 2 go into 8? 4 times, with no remainder. And that's how we simplify. But then, of course, we have to write our answer in a nice way. So 2 times 2 is 4. So our final answer for this problem would be 4 x squared y to the 4th root 2x. Okay? Number 2. Number 2, there are multiple ways to do a question like this. You could simplify each radical first and then put them together, or you can multiply them together first. So since they're both cube roots, we are allowed to do that. So the cube root of 16 times the cube root of 2 is going to give us the cube root of 32. Now x squared times x to the 4th, remember, is x to the 6th. When we multiply variables with exponents, we add the exponent. And then y to the 5th times y cubed is going to give us y to the 8th. Now for this 32, we're going to break it down the same way we did this one over here, but we would be circling groups of 3 instead. So since we know it's going to end up looking exactly like this example, the only difference we would do is circle groups of 3 at a time and box 2 leftovers. So this is actually going to end up being 2 cubed root of 4 on the inside. So it's going to flip-flop because of how many we have to circle at a time. Now, in terms of the exponents, 3 goes into 6 evenly twice, so we take out x squared with no remainder. 3 goes into 8 also twice, but we have a remainder of 1. That's how we end up with 2x squared y squared cubed root of 4y. Number 3, it looks like we can't do this because remember, when we add radicals, the inside of the radical must be identical. We cannot call this 66x on the inside of a 5th root. So what you need to do is first see if we can break anything down. Now this 64 can be broken all the way down using the factor tree, but I'm going to show you yet another way to simplify numbers. This is written as the 5th root of 2 to the 6th power x plus the 5th root of 2x. Now the reason why I did that is because I know that 2 to the 6th power is 64. And just like in the previous examples, I can now ask myself, how many times does 5 go into 6? Once, so I can take out 2 to the 1st power, if that helps you understand, with a remainder of 2. Now 5 does not go into 1 at all, so that just stays in there. So we have 2 5th root of 2x plus another 5th root of 2x, and that's going to give us 3 5th roots of 2x. Okay? So when you add, you must have identical radicals. Number 4 and number 5, that's dealing with division with exponents. And to do that, we just subtract. So we go to the side that has more. So there's 3 on the denominator, and there's actually 2 on the top that want to be in the bottom anyway. So you can just move those down based on the fact that they're negative, or you can just use subtraction. So 3 minus a negative 2 is 5. So we have x to the 5th in the denominator. And again, if you like moving negatives first, you can actually just move it to the top because it doesn't want to be in the denominator. So you have y to the 7th and y cubed, so that's going to give you y to the 10th. And of course, anything raised to the 0 power is 1. So we have our final answer, y to the 10th over x to the 5th. Now, when you're working with fractions, you still do everything the exact same way. So we have x to the 1/4, that would rather be on the top. So I'm just going to move him. And then we have 2/5 on top and 12/5 on the bottom for our y exponents. So we would subtract 12/5 minus 2/5, and that's easy to do. That's going to be y to the 10/5, which is just y squared. Now, if you have no idea how I just subtracted that, that's totally for another time. It's just subtracting fractions when we need a common denominator. But just type it in your calculator. In your calculator, just type 12 divided by 5 in parentheses minus 2 divided by 5 in parentheses. And then all you would have to do is math frac that, and it's going to tell you 2 if it, or whatever it is, if it's a fraction. In this case, it's just going to give you 2. Same with this. When we add those together, we need common denominators. So this is going to end up being 3/12 plus 8/12, which is going to give us x to the 11/12. Again, just type it in your calculator. This did not tell us that we had to write it in radical form. If it did, it would be the 12th root of x to the 11th power over y squared. But since the directions didn't say we had to do it, we can leave it right like that for this example, but either way is fine with me. And finally, for number 6, when you raise an exponent to another exponent, you multiply. So 8 times 3/4 is going to give us 6. So the top is going to simplify to x to the 6th over. Now we do not do that with numbers. This is saying 16 raised to the 3/4 power. So we do not do 16 times 3/4. What we would do, though, is we can type this in our calculator and just do 16 raised to the 3/4 power. It's going to give us 8. Or if you were to write 16 as 2 to the 4th power and raise that to the 3/4 power, that's going to give us 2 cubed, which is 8. Okay, but you do not multiply numbers by the exponent. You actually have to raise them to that power. Okay, so that's it for the first section. That is one of the amendments to this review packet that you should know. Another one is going to be number 14. When you get to number 14, this is a new style of question for this packet, and it should have been on the last year's one, but it wasn't for some reason. All we really have to do here is isolate the parentheses. So we're going to have x plus 5 to the 3/4 power is equal to 8. And now from here, we need to get rid of the 3/4 power. Well, to do that, all you have to do is raise both sides to the reciprocal power. Okay? And that will get rid of that part. So now you're just left with x plus 5 is equal to 8 to the 4/3 power. Again, you can just type that in the calculator, and if you have a number, you can use it. In this case, you will. So remember, this is like 2 cubed, so this is just going to become 12/3, which is 2 to the 4th power, which is 16. You don't believe me? Just type it in the calculator. Subtract 5 from both sides, and you get x is equal to 11. Now, the one thing you have to remember to do whenever you're solving radical equations of any kind, so even 12 and 13, what you need to do is substitute it back in to make sure you do not have an extraneous solution. So if you take 11 and plug it into x, you'd have 11 plus 5 is 16. 16 to the 3/4 power is going to be 8, and 8 minus 2 is 6, so it does work. But make sure you check for extraneous solutions whenever you are solving radical or exponential type equations. Those are the exact same. The last one is given the function fill in the inverse. So an inverse graphically is just a switch of x and y. So our x's come from the y values of the previous functions. So we have -5, -6, and -7. And our y's are our original x's. So remember, graphically, switch x and y's. And that would apply to a graph as well. If you were given a graph that was a square root or something, and I'm just going to pretend that this is 2, 2, and this is 2, or not 2, but 3, 5. If you wanted to graph the inverse, you would just switch your coordinates. You'd graph 2, 2, and then you would graph 5, 3, and, you know, all that kind of other fun stuff. So just make sure when it comes time, you just switch your x and y's when we graph. Logs. When you get to the log unit, everything should be the same. So we do not need to change anything for the log review. Now, in the trigonometry review, the video that you watched is going to start out with some SOHCAHTOA right triangle problems. There's no need for those for this review packet. So those have been cut. But the new section to trigonometry is number 12 and 13. That was not in the packet last year, so I'd like to cover them. When you are given one trig function, what you have to do is just draw your own right triangle. You can call theta any location you want. You could put it up here. And then you know that sine is opposite over hypotenuse, so we put the 3 over here and the 5 over there. But then when you're looking for the tangent of theta, you need opposite over adjacent, and we don't have the adjacent side. But good thing we have a friend named Pythagoras who created the Pythagorean theorem for us. And you can just set up the Pythagorean theorem and you'll find 4. So opposite over adjacent for tangent would give us 3/4. Okay? Now you would do number 13 the exact same way. You would set up your triangle. You would call one of your angles theta. It was given that tangent is opposite over adjacent, 40 over 9. To find the cosecant of theta, you have to remember that that is the reciprocal of sine. So we still need to use the Pythagorean theorem, and that'll give us 41. So the sine of theta is equal to opposite over hypotenuse, which is 40 over 41. But then you have to remember that the cosecant of theta is the reciprocal of that. So cosecant of theta is 41 over 40. Okay? And that should cover the changes in trigonometry. Finally, probability only has one change, and it's the addition of a two-way table. Now, when you're working with two-way tables, basically you just have to be very careful reading everything. So this is about students in math, and we have geometry, algebra 2 trig, and pre-calculus. So the first thing you'd want to do is add up your male students, which you should have 242 of them. If you add up the female students, you should have 254 of them. And if we go to adding geometry, we would add up geometry and get 80 students. There would be 228 algebra 2 trig students and 188 pre-calc students. And if we were to add all those classes together, or males and females together, we should end up with 496 total students combined. Okay, so this is total students for all of them. This is just your total amount of males, total amount of females, total students in geometry, algebra 2 trig, and pre-calc. So now it's important to understand that because we're about to read these very carefully. So find the probability that a random student is selected as taking pre-calculus. So what we're going to do is first realize that this is talking about a random student. It's talking about any random student. And there are 496 of those. But then we want to know if they're taking pre-calculus. This does not say a male in pre-calc or a female in. This is all pre-calc students. That is 188. So to come up with the probability, it's just how many students are in pre-calc divided by the total number of students, which is 496. And then you can write your answer as a reduced fraction of 47 over 124, or a decimal, which would be 0.379. Okay? So the next example, we're also going to find the probability that a random student, boom, it's just a random student, 496 again, is a male in geometry. So now we have to go to just males in geometry, which is 42. And then again, we just take 42 divided by 496, and that's going to give us a reduced fraction of 21 over 248, or a decimal of 0.0847. Okay? And the last one. Find the probability that a random female, so this time it's not talking about a random student. It's just talking about a random female, which in this case is 254 females. And that the female is also taking Algebra 2 trig. So now we have to just go find 112 female Algebra 2 trig students. And our setup for this one is 112 divided by 254. That reduces to 56 over 127, or we can write it as 0.4409 as a decimal. Okay, so again, this video just covers the changes to the packet. It's almost 17 minutes all by itself, and that was just the modifications. That's why we're not going to recreate the entire thing. All right, this is Longo, and I'm out. See you, bye.